Hello, everyone, and welcome to our webinar. Our topic today is titled Wall Bracing 2, the continuation of our series on the 2018 IRC wall bracing requirements. Welcome back to those of you who joined us last week, where we talked about load paths, lateral forces, and limitations. For those of you that missed part 1, it is available for on-demand viewing at www.apawood.org. During today's session, we will talk about the IRC bracing provisions for both wind and seismic. My name is Mary Ewer, and I am a manager in APA, the Engineered Wood Association's Field Services Division. I will serve as the moderator for this session. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood products and the systems where they are used. We also educate users and specifiers on the product's intended use and potential applications. Before we start today's webinar, I need to cover some housekeeping details. Ron's presentation will last about 50 minutes. Handouts with the slides can be found in the control panel on your screen. To ensure that everyone can hear clearly, we have muted all participants. We do encourage you to submit questions by typing them into the questions pane on the control panel. The panelists and I will answer some questions in the chat box as Ron is talking, and we will answer some in a Q&A at the end of the session. So please don't hold your questions until the end. We should have time to answer most of those questions. A recording of today's program will be posted on our website, www.apawood.org, in about a week. I'd also like to note that our webinar is approved for continuing education units, including AIA and ICC. About an hour after the conclusion of the webinar, an email will be sent to each attendee that includes a link where you can get your customized certificates of completion. Before we get started, I want to take a minute to introduce our team. Our panelists, Warren Hamrick and Matt Brown, will be helping me answer questions today and are the presenters for the other 2 sessions in this series, as shown here. Our speaker today is Ron Nuttall. Ron graduated from Texas Tech University with a degree in business administration and joined APA in 2017. He began his career with an APA member's distribution division in Texas and moved to Denver with the same member in 1996. He worked in sales of engineered wood products for 3 engineered wood products manufacturers before joining APA. His responsibilities for APA include consulting with large builders, professional designers, and code officials in the West Central United States territory. Ron conducts workshops and presentations for construction professionals on best practices for specification, selection, and application of engineered wood products, and is a provider of CEUs for designers and code officials. For those of you just joining us, welcome to the second webinar in APA's series on the 2018 wall bracing provisions of the IRC. I will now turn the microphone over to our speaker, Ron Nuttall.
Good day, everybody. So welcome to our second of 3 presentations on 2018 IRC wall bracing. A couple of resources that you'll be interested in are the book titled A Guide to the 2018 IRC Wood Wall Bracing Provisions, which was authored jointly by the ICC and APA, and is available on the ICC website, iccsafe.org. Another resource is the publication Introduction to Wall Bracing, which can be found at apawood.org. During this webinar series, we're working from left to right through the topics shown on these tabs. Last week in our first series, Matt covered the horizontal forces acting on a house and how they are resisted. The code prescribed limitations to prescriptive wall bracing and introduced braced wall lines. Today, we will begin with braced wall panels and go through the steps to determine the required length of bracing. Next week, in part 3, Warren will work through some examples using what we learned in parts 1 and 2, and then review the IRC simplified wall bracing, APA simplified wall bracing, and introduce our wall bracing calculator. The code defines a braced wall panel, or BWP, as a full height section of a braced wall line, or BWL, with no vertical or horizontal offsets. Brace wall panels can be spaced a maximum of 20 feet apart when measured edge to edge. As mentioned earlier, the BWP is the lateral resisting element of a braced wall line. As Matt mentioned last week, the IRC defines a braced wall line as a series of braced wall panels in a single story. There are 12 intermittent bracing methods, and these are the first 6. But we'll note that on BVWSP, we will be discussing that in detail during our seismic section. And these are the other 6 bracing panels methods, and we'll cover them all in the following slides. The first one is method LIB, or lead-in bracing. It's a diagonal brace that is required to extend from the bottom plate to the top plate. The code defines the rectangular area surrounding the brace as a BWP. The length of this type of BWP depends on the height of the wall and the angle of the brace. Code states that the angle is to be 45 to 60 degrees from horizontal, and the diagonal member can be a 1x4 board or an improved metal strap. In seismic categories, lead-in bracing is permitted in the following cases. The top 2 stories in seismic design categories A, B, and C for 1 and 2 family dwellings, and in townhomes in seismic design category C only on the single story or top level in a 2 or 3 story dwelling. It is not permitted in categories D0 through D2. Here's an example of method lead-in bracing. Code specifies that the diagonal brace, like I said, must be installed at 45 to 60 degree angle, and it must be continuous from the bottom plate to the top plate. The interior of the panel has to have gypsum or wood structural panel, which is not shown for clarity. No openings may be cut through the diagonal member, and no openings may interrupt the rectangle made by circumscribing a rectangle around the diagonal brace. For example, the studs at the end of the diagonal brace may not be cut. But potentially a small window fully within the circumscribed rectangle will not interfere with the action of the braced wall panel. Since a diagonal brace is required to be continuous from the bottom plate to the top plate, it cannot be installed as shown here. This type of installation results in a discontinuity. Method DWB, or diagonal wood boards, is a very strong system. It's even better than wood structural panels, but it is labor and material intensive, and a lot more fasteners are required. This is an example of diagonal wood boards. These sheathing boards were exposed during a renovation project. If you note on the lower left-hand corner, they shifted to horizontal board sheathing, which is a very poor substitute for bracing because it's only 1/6 as strong. Horizontal sheathing with boards is no longer permitted in the IRC, but there are design values in the American Wood Council's reference SPIDWIZ, or Special Design Provisions for Wind and Seismic. Method wood structural panel is a wood structural panel that is 48 inches wide. Section R604 gives the definition of a wood structural panel as plywood or OSB conforming to Product Standard 1 or Product Standard 2. Based on wind speed, exposure category, and joist spacing, the minimum thickness may be 7/16 of an inch, and nailing may be an 8-penny minimum. Blocking is required at all horizontal edges of BWPs. No blocking is required on infill sheathing, which is not considered a BWP. In this picture of tornado damage, you can see that the garage bottom plate is still in place with stud nails sticking up at 16 inches on center. Note the narrow strip of OSB wall sheathing still attached to the bottom plate. Continuity of the wall could have been greatly enhanced had the OSB wall sheathing been better attached to the framing by blocking at the horizontal edges. Here's an example of method WSP, wood structural panel. The panels are required to be 48 inches in length. Method SFB is structural fiberboard sheathing. Code states that the minimum thickness is 1/2 inch and it must be installed on stud space not greater than 16 inches on center. Minimum fastener spacing is 3 inches on center along the edges and 6 inches on center over intermediate supports. The nailing was increased to match other panel type products' shear capacity or lateral resistance. Here's an example of method SFB, structural fiberboard. The panels are required to be 48 inches in length unless you use the partial credit table in R602-10-5-2. Method GB is gypsum board. When gypsum is installed on one side of the wall, the minimum brace wall panel length is 96 inches. If it is installed on both sides of the wall, the minimum length is 48 inches. Minimum thickness is 1/2 inch and maximum stud spacing is 24 inches on center. Floating corners are not allowed. A floating corner occurs when the edge of the gypsum board is not fully supported by a framing member, like when your drywall clips are being used. This is an example of method gypsum board. There are drawbacks to using this method. GB requires tighter fastener spacings, 7 inches on center, than what is normally used by drywallers, and it needs to be inspected before the taping and floating is done, as seen in this photo. Method PBS is particle board sheathing. Note the spacing of the fasteners, 3 inches on center around the edges and 6 inch on center over intermediate supports, and the 16-inch on center stud spacing. As with structural fiberboard, the nailing is increased to match other panel types' shear capacity. This is method PCP, Portland cement plaster. When using this method, the code states that it must be Portland cement. Therefore, gypsum plaster is not acceptable. The BWPs are required to be 48 inches in length unless using the partial credit table mentioned earlier, and the maximum stud spacing is 16 inches on center. Here's an example of method Portland cement plaster. This method, HPS, is hardboard siding. Fastener spacing is 4 inches on center around the edges and 8 inches on center over the intermediate supports, and the studs are spaced at 16 on center max. The nailing is also increased to match other panel types' shear capacity. This is method HPS, hardboard panel siding. The panels are required to be 48 inches in length unless you're using the partial credit table mentioned earlier. And this is table R602.10.5, showing the minimum length required for the intermittent bracing methods. As you can see, the minimum lengths increase as the wall height increases. BWPs having a length less than 48 inches will now be permitted in intermittent bracing. However, their effective length will be reduced, and it applies to DWB, WSP, SFB, PBS, PCP, and HPS only. The next 3 intermittent methods can be used when a BWP is less than 48 inches. The first is method ABW, alternate braced wall. This method allows you to have a braced wall panel that is less than 48 inches, but counts 48 inches toward the bracing requirements. They can only be used in 1-story dwellings or the first of 2 stories. This method has been in the code since the 1994 UBC. This table gives the minimum lengths, which are based on seismic design categories and height, wall height. In the low seismic areas, the panels can be as tall as 12 feet. In the higher seismic areas, the ABW is restricted to a height of 10 foot. Just a reminder, there are minimum lengths, but if you meet these requirements, you can count 48 inches as qualified bracing. ABWs require hold downs. Either the strap type or bolted down hold down are approved for use. Construction of this BWP requires 3/8 inch minimum performance category wood structural panel, which is either plywood or OSB. The capacity of the hold downs are given in IRC table R602-10-3-2. The hold down capacity is a function of the panel length. If the APW is supported a story above, it must be nailed at 4 inches on center maximum. And now we get to portal frames, my favorite subject. Luckily for me, we have an on-demand webinar where the details are covered more in depth. It's portable frames built right and is available on our website, apawood.org. So I will just be touching on the basics of these methods. This first method is PFH, or portal frames with hold downs. PFH requires an extended header. This method can be as narrow as 16 inches for a one-story, but must be 24 inches if the BWP supports a story above. Method PFH braced wall panels are permitted to replace each 4 foot of braced wall panels. PFH must be constructed from plywood or OSB. The required hold down capacity is 3,500 pounds for both the 16-inch and 24-inch construction. The 1,000-pound strap is applied to the opposite side from the sheathing. If you notice the extended header and the grid nailing at 3 inches on center. This is a moment resisting connection that allows the BWP to be narrow. The 3-inch on center nailing is required at the double stud on each side and at the bottom plates. In taller walls using PFH, the wall height can be up to 12 feet tall. The portal height is limited to 10 foot to the top of the header. A pony wall can be built above the portal header, but the maximum pony wall height is 4 feet. They also require tension straps per table R602 10-6-4. The number of jack studs required for a single portal post is found in tables R6027, parentheses 1 and parentheses 2. PFH can be built as a single portal or a double portal. When it's built as a double portal, there's a BWP at both ends of the header. In this case, each BWP is equivalent to 4 feet of bracing. The 1,000-pound strap are required between the jack studs and the header to resist hinging when a load is applied perpendicular to the wall. In the case of a single portal, a 1,000-pound strap is required connecting the foundation and the jack studs supporting the other end of the header. Notice the top plate is nailed into the header with 16 penny nails. As I mentioned earlier, all these details are covered more in depth in APA's on-demand webinar, Portal Frames Built Right. The next method is portal frames at garage, or PFG. It also requires an extended header and can be as narrow as 24 inches. PFG must be constructed from 7/16" plywood or OSB. Note the extended header and the grid nailing at 3 inches on center. Also notice the 2 anchor bolts and no hold downs. The 3-inch on center nailing is required at the exterior studs only, and only 1 bottom plate is required. This portal configuration is worth 1.5 times its actual length. So a 32-inch long portal is equivalent to a 48-inch braced panel. Here's the construction detail for the continuously sheathed portal frame with a 6:1 aspect ratio. The tension strap capacity varies with height of the pony wall, opening width, wind speed, and exposure category. Reference table R602 10-6-4 for the required tension strap strength. A 1,000-pound strap works for walls that do not have a pony wall above the opening. If you noticed in note 1, you must fasten the sheathing to the header with 8 penny common or box nails in a 3-inch grid pattern as shown. Note 2, if needed, panel splice edges should occur over and be attached to common blocking within 24 inches of the wall's mid-height. 1 row of 3-inch on-center nailing is required in each panel edge. And in note number 3, the minimum length of the panel is found in table R602 10-5. In method PFG with taller walls, wall height can be up to 12 feet. The portal frame height is limited to 10 feet, measured to the top of the header. And a pony wall can be built above the portal header, 4 foot being the maximum height allowed. They require tension straps per table R602 10-6-4, and the number of jack studs required for a single portal post is specified in table R6027, parentheses 1. This table is a quick way to look up the minimum lengths for the different intermittent methods based on the wall height. The table also gives you the length that actually contributes to the wall bracing requirements. Other products can be used as brace wall panels if they have a code report. The code report defines how the product must be installed to qualify as a code-compliant braced wall panel. These are examples of proprietary systems that may be used with the proper documentation and installation. Now we'll talk about the 4 continuous sheathing methods. For all 4 methods, the braced wall lines must be fully sheathed, including the gable ends. Continuous methods allow for narrow BWPs without hold downs and must be fully sheathed with wood structural panels or structural fiberboard sheathing. The sheathing requirements for continuous methods are all full height areas are to be sheathed. The areas above and below openings must also be sheathed. Some of the full height areas may qualify as braced wall panels, and the openings in the wall determine how wide the BWPs have to be. The sheathing above and below openings and the sheathing that is too narrow to be a BWP make connections between the BWPs in the wall line. These connections make the wall behave like a long wall line, therefore allowing the BWPs to be narrower than 4 feet. This concept will be explained in the slides that follow. The opening height is measured from the top of the opening to the bottom of the opening. It is not measured from the top of the opening to the bottom of the wall. Blocking is required at all horizontal edges of BWPs. The infill panels do not need blocking. For continuous sheathing methods, the entire building must be sheathed, including gable ends. However, not every sheathed area has to be the length requirement of the BWP. The wall line only has to have enough BWPs to meet the placement and meet the replacement requirements and the length requirements of Table R602-10-3, parentheses 1 through 4. The opening in the wall line determines how wide the BWP has to be. If a section of bracing has openings on either side, the taller opening determines the minimum bracing length. Using IRC Table R602-10-5 with the adjacent clear opening height and the wall height, you can determine the minimum length of braced wall panels that can count toward the required bracing. The table continues with opening heights up to 12 feet, as well as CSG and CSPF, which we'll talk about in a minute. Note that these 2 methods, the max header height is 10 feet with a wall height up to 12 feet if a pony wall is used. This is method CSG, or continuously sheathed garage. It can only be applied to one garage line. It can be applied to both sides of the garage opening, and a wall can have up to 4 openings. This is not a portal frame. It is a regular framed wall with a header. It's a really special case of the CSWSP, and it does come with limitations. For a continuously sheathed home, the walls on either side of garage openings are permitted to have an aspect ratio of 4:1. For an 8-foot wall, the brace may be as narrow as 24 inches. A 9-foot tall garage return wall would have to have be at least 27 inches wide. It is not necessary to have an extended header over these narrow walls beside the garage opening, but a header must be placed next to the panel on jack studs. See footnote C in Table R602-10-4 for more information. This provision is limited to a single story with a light roof covering for seismic requirements only. In lower seismic regions, there is no roof weight limit, per footnote B in Table R602-10-4. This is because the weight of the roof has no negative impact on wind loads. In fact, the additional weight helps increase the uplift resistance. What if we have a story above the garage or we have a tile roof? CSPF makes use of the extended header BWP that we discussed earlier, but without hold downs and with continuous sheathing. Furthermore, similar to PFH, CSPF may be used throughout the structure including on raised floors. The construction is somewhat similar to PFH. It's different in that it doesn't have hold downs and can be as narrow as 16 inches in length. CSPF contributes 1.5 times the actual length to the bracing requirements in seismic design categories A, B, or C, and contributes its actual length in seismic design categories D0 through D2. Here's the construction detail for the continuously sheathed portal frame with a 6:1 aspect ratio. The tension strap capacity varies with the height of the pony wall, opening width, wind speed, and exposure category. See Table R602-10-64 for required tension strap strength. A 1,000-pound strap works for walls that do not have a pony wall above the opening. Once again, in note number 1, fasten sheathing to the header with 8-penny common or box nails in a 3-inch grid pattern as shown. And if needed, panel splice edges should occur and be attached to common blocking within 24 inches of the mid-wall height. 1 row of 3-inch on-center nailing is required in each panel edge. And the minimum length of the panel is found in Table R602-10-5. I just want to take a moment here to mention that the panel splice location is one of the most common mistakes I've seen with these type of installations. It's important that it be close to the mid-height of the wall. Table R602-10-6-4 gives you the required strap capacity based on stud framing, pony wall height, and opening width. When you see DR, it means it's outside the scope of prescriptive design and must be reviewed by a design professional. This is a continuation of the previous slide. As I mentioned earlier, more details on all portal frames can be viewed on our on-demand webinar, Portal Frames Built Right. The garage on the left could be built using CSG on the front walls that have a 4:1 aspect ratio, or 24 inches for an 8-foot wall height. Again, these BWPs are not permitted to support a story above. If the BWPs have less than a 4:1 aspect ratio, CSPF has to be used. The tucked-in garage must be built using CSPF because the story above is being supported by the braced wall panels. Note that the wall that has the CSPF in it must meet both the length and placement requirements for that braced wall line. The last continuous method is continuously sheathed structural fiberboard. The minimum length requirements are based on opening heights adjacent to the panels and are the same as what we covered for CSWSP. All continuously sheathed braced wall lines must have one of these 5 end conditions shown. For these end conditions, the return panel requirement in condition 1 in a wood structural braced wall line, the return panel must be 24 inches minimum, and in a structural fiberboard braced wall line, the return panel must be 32 inches minimum. In condition 2, in lieu of a return panel, an 800-pound hold down may be fastened at the corner stud. And in condition 3, if you have a full-length 48-inch braced wall panel at the corner, no corner return is required. For condition 4, in the wood structural panel braced wall line, the sheathed corner panel D must be 24 inches minimum, and its return panel must also be 24-inch minimum. For the structural fiberboard braced wall line, the corner panel D must be 32 inches minimum, and its return panel also must be 32 inches. In condition 5, in lieu of a corner panel, an 800-pound hold down may be fastened to the end of the BWP closest to the corner. Note that these 800-pound hold downs often travel in pairs. If 2 continuously sheathed wall lines meet at a corner and one does not have a panel at the corner, both walls lose the restraint at that corner and each may need an 800-pound hold down. Now we are able to mix methods with certain rules. Code permits a variation in bracing methods between stories. The IRC also permits a variation in bracing methods between braced wall lines of the same story. This includes continuous sheathing. This means that the entire structure will not have to be fully sheathed. In the higher seismic design categories, the entire story will have to be fully sheathed, but not the entire structure. In Table R602.10.4.1 in Item 3, the braced wall panel method variation within a braced wall line is permitted only in seismic design categories A and B, and for detached homes in category C with intermittent bracing. The greatest required bracing length for panel materials must be used, and it is not applicable for use with continuous sheathing or dwellings in seismic design category D0 through D2. Item 4 states that mixing CSWSP, CSG, and CSPF along a braced wall line is permitted in any seismic design category. While Item 5 states that the braced wall panel method variation in a braced wall line with continuous sheathing on exterior walls and intermittent on interior walls is permitted only in seismic design categories A and B, and for detached houses in seismic design category C. The greatest required bracing length for all panel materials in a braced wall line must be used. Once again, this is not applicable for dwellings in seismic design categories D0 through 2. For intermittent bracing methods, there are 3 placement requirements that are useful to memorize. The BWP is to begin no more than 10 feet from the end of a braced wall line. The braced wall panels must be located not more than 20 feet on center from edge to edge. A minimum of 2 BWPs per braced wall lines when the braced wall line is greater than 16 feet, and a minimum of 1 48-inch braced wall panel or 2 reduced length panels if the braced wall line is less than 16 feet. Here we have BWPs that are 6 and 10 feet wide. For the 2009 earlier codes, ICC interpretation measured from the center of an assumed 4-foot BWP, which made the unbraced length 21 feet. The code itself never stated how far into the panel that center measurement was to be done. Therefore, larger panels could require a smaller unbraced distance between them. It didn't make any sense, so with the 2012 IRC, braced wall panels now may be spaced up to 20 feet apart, edge to edge, period. No other measurements are required. The new provision more clearly represents the intent of the code and the principle of spreading out the resistance along the line of force. BWPs may be located 10 feet away from the end of the braced wall line when using wind requirements only. So let's look at some examples. Does this wall line meet the IRC code provisions? The braced wall panels are spaced 28 feet apart. The braced wall panels are within 10 feet of the braced wall line, and the BWPs meet the minimum requirement length. But because the 20-foot spacing, on-center spacing maximum is exceeded, this would not meet a prescriptive design. So does this meet the IRC provisions? The longest BWP spacing is 16 feet. The braced wall panels are within 10 feet of the end of the braced wall lines, and the braced wall panels meet the minimum width requirement. So yes, this particular model does meet code prescriptions. And we'll look at this one last one. Does this meet the code with an 8-foot high ceiling, wall height? The widest BWP spacing is 16 feet. One braced wall panel is 12 feet from the end of the braced wall line, and the braced wall panels meet the minimum width requirement. So no, this one does not meet the requirements because the braced wall panels are more than 10 feet from the end of the wall. Does this meet the IRC code provision? The widest BWP spacing is 16 feet. One braced wall panel is 12 feet from the end of the braced wall line. The braced wall panels meet the minimum width requirement. Oh, excuse me. So it did not meet the end of the wall. Now we get to the last part of the presentation, required lengths of bracing. When determining the required length of bracing, wind speed must be taken into consideration, and depending on the location of the house, seismic risk must also be considered. We will now go over how to determine the required length for wind and seismic. If you're in an area where seismic considerations must be considered, the required lengths for both wind and seismic must be determined with larger length controlling. Other construction details such as hold downs must be applied regardless of which requirement controls. There are two bracing length tables, one for wind and one for seismic. The required bracing length is the maximum of the two tables' bracing lengths times all the adjustment factors, which we will go over next. We'll do wind first. So we determine the required length of bracing by locating the correct row and column using the wind speed, story location, braced wall line spacing, and bracing method. This is a table from the IRC that will determine the required length of bracing. Determine the length of bracing by locating the correct row and column using the wind speed, story location, braced wall line spacing, and bracing method. In the upper left corner, this table is based on exposure category B with 30-foot mean roof height, 10-foot wall height, and 2 braced wall lines. If any of these factors are different, the amount of required bracing will need to be adjusted. The wind bracing adjustment factors are wind exposure category, eave to ridge height, story height, number of braced wall lines, 800 hold downs on the top story, interior gypsum board finish, gypsum board fastening, and horizontal blocking. The total adjustment factor is the total of these factors which would apply to the braced wall line. The first factor is the exposure category, which Matt covered last week. Note that table R602.3.3 parentheses 1 is based on exposure category B. So value here for exposure B is 1.0. But new to the 2018 IRC, footnote D can change the factor. An example of this is a house on a large body of water. You can't say that the side of the home facing the lake is exposure D and the rest of the home is in exposure B and then factor accordingly. Now the entire structure has to be designed as exposure D. Adjustment factor number 2 is the roof eave to ridge height. When wind blows on a house, the larger the area, the greater the load, like a sail on a boat. The factors go up as the eave to ridge height increases. If you're wondering why the factors are higher or lower if less than 10 feet for single story versus multi-story, it's because the roof eave to ridge height is a larger percentage of the total area of the house when it's a single story. If you compared the effects of increasing the eave to ridge height from 10 feet to 15 feet on a single story house versus a 3-story house, the percentage of area increased is much greater on the single story. Adjustment factor 3 is story height. Table R602.10.3 parentheses 1 is based on a 10-foot story height, so adjustment for 10 feet here is 1.0. 12-foot story height is just for linear interpolation purposes only, since the story height is limited to 11 foot 7 inches. The 2018 IRC changed terminology from wall height to story height in table R602.10.3 parentheses 2, but not in parentheses 1. That causes a conflict. Story height is defined in section R202 as top of floor to top of floor. Wall height is not defined. Here's a visual of what I just mentioned. For the purposes of wall bracing adjustments, we now reference the story height. Adjustment factor number 4, table R602.10.3 parentheses 1 is based on 2 braced wall lines. So adjustment for 2 braced wall lines is 1.0. Note that this applies to each direction at each story. Adjustments are based on the reduced braced wall line spacing resulting from the use of interior braced wall lines. Adding more braced wall lines will result in less space between the braced wall lines, which will require less bracing, but then this adjustment factor must be applied. The adjustment is for all parallel lines, not just the interior lines. On occasion, an exterior wall line will require two separate braced wall lines. Adjustment factor number 5 is applicable with these methods to the top story only because it does not have mass of stories above it to help resist the overturning forces due to the wind. They're stalled in both ends of each braced wall panel, and a continuous load path to the foundation is required. Adjustment factor number 6 is applicable to these bracing methods. When a finish is omitted from the inside face of braced wall panels, which is only likely to occur at gable-end walls, walkout basements, and exterior garage walls. Adjustment factor number 7 covers gypsum board fastening. This factor is applicable when panels are fastened at 4 inches on center at the perimeter and all horizontal joints are blocked. We noted earlier that minimum fastener spacing is 7 inches on center with methods GB, so this adjustment credits the use of more fasteners. This only applies to perimeter fasteners. Fasteners in the field can remain at 7 inches on center. Adjustment factor number 8 is a big one in my opinion, in that if horizontal blocking is omitted, you need twice the number of braced wall panels. But this can work on some garages and sidewalls without affecting your design much. In the 2015 IRC, braced wall line spacing only applies to some of the methods, but now in the 2018 IRC, braced wall line spacing requirements apply to all methods. In this example, for the braced wall line spacing for line 1 is 10 feet. In braced wall line 2, the spacing is the average distance between lines 1 and 3, which is 17.5 feet. In braced wall line 3, spacing is the average between lines 2 and 4, which equals 20 feet. And then braced wall line 4 spacing is at 15 feet. So now let's look at the seismic bracing requirements. If the structure is a detached 1 or 2 family in seismic design category D or greater, or townhomes in seismic design category C or greater, you must also consider the seismic bracing length requirements. You then compare the required length from the wind tables, and the longer length will control. Determine the required length of bracing by locating the correct row and column using the seismic design category, story location, braced wall line length, and bracing method. One difference you will notice is you enter the table with the braced wall line length instead of the braced wall line spacing. As with wind, after you determine the required length of bracing, the next step is to apply the adjustment factors, which are story height, braced wall line spacing, wall dead load, roof ceiling dead loads, walls with stone or masonry veneer, interior gypsum board finish, and horizontal blocking. So all these adjustment factors apply to your seismic designs. If your story height is 10 feet or less, no adjustment is needed. Over 10 feet, you must multiply by 1.2. If you're looking at a townhouse in category C and the braced wall line spacing is less than or equal to 35 feet, no adjustment is required. If the braced wall line spacing is greater than 35 feet up to 50 feet, the adjustment factor is 1.43. Remember, if you're in category C, detached 1 and 2 family dwellings are exempt from seismic requirements. In category D, these adjustment factors apply to both townhomes and single and 2 family dwellings. Braced wall line spacing less than 25 feet require no adjustments. Over 25 feet but less than or equal to 30 feet is multiplied by 1.2. Over 30 feet but less than or equal to 35 feet is multiplied by 1.4. The next adjustment factor is the wall dead load. As Matt covered in the first webinar, the seismic load is determined by the mass of the structure. If the wall dead load is between 8 and 15 psf, no adjustment is needed. If the wall dead load is less than 8 pounds per square foot, you're able to take a reduction and can multiply the required length by 0.85. Continuing the dead load adjustments, we next looked at the roof ceiling dead loads. The baseline is less than or equal to 15 pounds per square foot, which doesn't need an adjustment. If the structure is a 2 or 3 story building and the roof ceiling dead loads are greater than 15 psf and less than or equal to 25 psf, the adjustment factor is 1.1. On a single story or top story with loads greater than 15 psf and less than or equal to 25 psf, the adjustment factor is 1.2. The next adjustment factor is for buildings in category C, therefore it only applies to townhomes. If the townhome has walls with masonry or stone veneer and the braced wall lines are on the top story or a single story, no adjustment is needed. If the braced wall lines are on the first level of a 2-story or the first or second level of a 3-story, the adjustment factor is 1.5. Now we'll get into the adjustment factor for wood BVWSP, which is wood structural panels with a stone or masonry veneer. This applies to detached 1 and 2 family dwellings in categories D0, 1, and 2. For details on this method, we're referred to Table R602.10.6.5. Note that townhomes with stone or masonry veneers in category D0 through 2, the wall bracing should be designed by an engineer. Using the BVWSP method, this table is where you determine the required length of bracing. Similar to the previous seismic table, the length of bracing will be determined by this design category, the story location, and the braced wall line length. Figure R602.10.6.5 gives further detail on how to properly construct the BVWSP method. As you can see, it's complicated. This factor alone is why I'm so thankful I don't have to deal with seismic designs in my territory. The next adjustment factor applies to method WSP and CSWSP used for single family or 2 family dwellings in categories D0 through D2. If you're using these methods and have stone or masonry veneer on the first or second story of a 2-story dwelling, the required length should be multiplied by 1.2. This is an option to admit the interior gypsum board as long as you adjust the required bracing by 1.5 times. This applies to the methods as shown in this slide. This option usually will apply to a garage or basement where you want the option of not finishing the interior of the wall line. The last adjustment factor applies both to methods WSP and CSWSP. As with wind factors, if you choose not to block the horizontal joints, you will need to provide twice as much bracing. These slides were introduced earlier, but after going through the wind and seismic table, let's review. The first step is to determine if you are in the seismic design category, which would exempt you from looking at the seismic requirements. Much of the country does fall into this category and can ignore the seismic section. If you do happen to be in a higher seismic area, you must calculate the required length for both wind and seismic and adjust that length with the appropriate adjustment factors. After this is completed, you compare the lengths required and the longer length will control. I find this decision tree helpful to think through the process. Let's take a quick look at a quick example. The wind table applies to all structures while the seismic table has subcategories that determine how it is applied. In this example, how much bracing is required for the braced wall line shown here in the elevation encircled on the plan view? The braced wall line is 40 feet and the braced wall line spacing is 25 feet. We will assume exposure category B, eave to ridge height of 10 feet, 9-foot story height, 2 braced wall lines, 7 psf wall dead load, and 15 psf roof ceiling dead loads. And for simplicity's sake, no stone veneer. First, we go to the wind table. We will assume 110 mile per hour ultimate wind speed, the bottom of a two-story structure, and the CSWSP method. Our brace wall line spacing was 25 feet, so we'll round up to 30, which is conservative. If we aren't able to meet the requirements, we can always come back and interpolate. The required length of bracing using method CSWSP for the bottom of a two-story structure in 110 mile per hour ultimate wind region is 8 feet. In our example, the exposure category is B, so no adjustment is needed. Our example has an eave to ridge height of 10 feet, so once again, no adjustment needed. We're able to take a small reduction due to having a 9-foot story height. We can adjust the required bracing by 0.95. We have two braced wall lines, so again, no adjustment is needed. Now we take all these adjustments and apply them to the 8-foot the table told us we needed. Exposure adjustment is 1, eave to ridge height adjustment is 1, wall height adjustment is 0.95, braced wall line adjustment is 1. After multiplying all these adjustments, we need 7.6 feet of bracing for wind requirements. So now let's check the same wall for seismic. We'll start by getting the adjustment factors. Our story height is 9 feet, so no adjustment needed. We're right at the limit for spacing, so luckily we can ignore this one as well. 7 pounds per square foot for the wall dead load gives us a 0.85 adjustment. And the bottom of 2 stories with the roof ceiling dead load of 15 pounds per square feet is a factor of 1. Thankfully, we get to ignore our masonry and stone veneer. So we're going to assume the walls have gypsum, and we can ignore this factor. And all BWPs are blocked, so we will ignore this one as well. Since our brace wall line length is 40 feet and we're using CSWSP, the required length of bracing for the bottom story of a 2-story structure in seismic design category D0 is 12.8 feet. Now we take all the adjustments and apply them to the 12.8 feet the table told us we needed. The dead load adjustment is 0.85 and all the other adjustments are 1.0. So after multiplying all the adjustments, we need 10.88 feet of bracing, which we'll round up to 10.9 feet. So we've checked both wind and seismic, and now we need 10.9 feet of brace wall panels required for the seismic. We determined the minimum lengths that will count. This is going to be a function of the adjacent openings. In our case, we're planning to use CSPF on both sides of the garage. So those piers must be a minimum of 18 inches. We have a door opening of 92 inches, which the adjacent piers must have a minimum length of 37 inches. Our window opening is equal to or less than 64 inches, so we need a minimum of 27 inches next to the window. We have 24 inches on either side of the garage, so we meet the minimum for CSPF, which in seismic zone D0 count for their actual length. There is a 48-inch braced wall panel to the right of the front door, and we needed 27 inches minimum next to the window, and that's exactly what we have on the far right. So added together, we only have 10.25 of braced wall panels, which is just short of the 10'9" we need. But we can use the 48 inches of braced wall panels to the right of the garage door because CSPF allows us to count the actual length of that BWP, and that gives us a total of 12.25 feet of braced wall panels. This is in compliant with all the IRC requirements. So this concludes today's presentation, and I will turn the mic back over to Mary.
Thank you so much, Ron. We have had a number of questions come in during your session that we have been answering as you've been talking. But before we jump to those, I want to point out that you can see a QR code on your screen right now. If you open the camera on your smartphone and point it at that code, a link will pop up that will take you to a survey on this session. That same link will be emailed in about an hour. We'll leave this QR code up during our Q&A session, so it'll be up there for a little bit, but I wanted to point it out in advance. So Ron, like I said, we've had a number of questions come in. Can you go back one slide for me, Ron?
Oh, sorry.
It's all right. Those buttons are tricky when you've just been talking that long. The first question is, can you talk about the fastener spacing requirements for braced wall panels?
Well, that depends on the material used for the braced wall panels. Fastener spacings range from 3 inch to 7 inch on center around the perimeter or edges, and from 6 to 12 inches on center in the middle of the panel. It's these fasteners that transfer the panel's resistance to racking into the structure to which they're attached. Infill panel fastenings are not as restrictive as it is for the BWPs. And for plywood and OSB wall sheathing, the fasteners should be 6 inches on panel edges and 12 inches in the field.
Great, thank you. Is there a limitation on how close the edges of braced wall panels should be to the top or bottom plate of a wall?
Not really, but remember the fasteners along the joining edges of the panels must meet spacing requirements for that particular material used. Like in methods CS portal frame with hold downs, and portal frame garage, any panel joints must be within 2 feet of the middle of the wall. And that is, this is shown in the details in the code.
Great, thank you. We had a number of questions on the wind adjustment factor where 3 or more braced wall lines require an increase in the amount of braced wall panel. Can you discuss that one for me a little bit?
That's counterintuitive to me as well. And at first glance, the adjustments give the impression that the additional interior braced walls is a disadvantage. And although that's true, it is misleading. For example, the distance between 2 exterior wall lines is too great that it requires an interior braced wall lines. So because the spacing of braced wall line decreases, the actual amount of bracing for each wall also decreases.
Okay, so while it seems counterintuitive, because you're going in with a smaller braced wall spacing, it doesn't really increase the load as much as it seems like it would.
Right.
Great, thank you. On mixing methods, are there any limitations to mixing braced wall methods?
Yeah, one limitation applies to the continuously sheathed methods, and the other applies to seismic zones. Mixing intermediate methods can be used in a braced wall line in combination with continuously sheathed methods, provided the length of the required bracing is determined using the highest value of the methods. But mixing methods is restricted in seismic zones C and D0 through 2, and a good guide to the mixing methods is found in Appendix F on the guide to the 2018 IRC wall bracing provisions.
Great. And then last question, we are running out of time here. Why are seismic adjustments different than wind adjustments?
Seismic and wind are totally independent of each other, and the adjustment factors are based on the different loads. The amount of bracing required for seismic loads is directly related to the mass or the weight of the structure. Wind requirements relate to the pressure of the wind blowing on the side of the house or the building. The adjustment factors in the prescriptive tables are based on the engineering principles that were developed by an ad hoc ICC committee, which included an APA technical team member. So because of the differences in the loadings and the way that the buildings react to those forces, it is important to check both wind and seismic using the greater bracing requirements.
Wonderful. Thank you again, Ron, and thank you to our panelists, Matt and Warren. As you were talking, Ron, I was assigning them questions, and they have done a wonderful job of helping me get most of those answered. If you did have a question we did not get to, we will share those with the rest of our team, and someone will get back to you as soon as we can. Before we conclude, I'd like to touch on a few quick things. First, please remember to participate in our survey. As I mentioned earlier, it can be found either in your control panel or through a link in an email that'll be sent soon. We value that feedback and spend a lot of time reviewing it and always trying to make our next presentation better. Also, make sure you join us next week for the final webinar in our wall bracing series. Don't forget to download the AIA or ICC Certificate of Completion from the links in the follow-up email that will be sent in about an hour. And finally, make sure you're signed up to receive our APA update newsletter so that you will be notified of future webinars and updates to APA publications and standards. To receive it, all you need to do from our homepage is to click on Sign in the upper right-hand corner of the page. In the drop-down menu, simply select Register. Then you will need to let us know what you would like to receive from APA, in this case, the APA update newsletter. Today's team are just some of the field staff we have throughout the country. These talented people are available to assist design professionals, builders, and code officials. Their individual contact information can be found on our APA website, www.apawood.org. Please feel free to reach out and take advantage of this resource. And as I mentioned earlier, a recording of today's webinar will be posted at apawood.org soon. Don't forget to join us next week when we go through a full house example and learn about simplified methods and APA's wall bracing calculator. And with that, I would like to thank you for attending. Have a great day.